Dear children, today I am giving the second video of the first lesson number system. The today's topic is irrational numbers. Last class we learn up to rational numbers, and today's topic irrational number, which is totally opposite to rational numbers. The last class we learned about integers also. Integers, we can't find any smallest integer, we can't find the largest integer. See the integers containing 0, right hand side to 0 all are positive natural numbers, and left to 0 all are negative of natural numbers. So these are together forming the group of integers. And next we also learned about rational numbers. Rational numbers means the numbers which are in the form of numerator by denominator. Here you see all the numbers are in the form of numerator by denominator, and these are not in the form of numerator by denominator, which normally use the symbol p by q or a by b. So these numbers are not in the form of numerator by denominator. But then also, if there is no denominator, then always we find the denominator as 1. So this minus 7 means minus 7 by 1, 5 by 1, 0 by 1. They can also written in the form of p by q or in the form of a by b or numerator by denominator. So all are rational numbers. And also, apart from that, the most important property was that the numerator and denominator both should be integers. Then only it will be your rational numbers. But if I give one example like this, root 2 by 3. So see, this is also in the form of numerator by denominator or a by b or p by q. But thing is that as for rational numbers, both numerator and denominator should be always integers. But here you see, we are also having this in the form of numerator by denominator. But numerator is root 2, which is not integer, because in a family of integers we cannot having any numbers containing root over sign. So the numbers containing root over sign cannot be treated as integers. So here you see the number is having numerator by denominator, but numerator is root 2, which is not integer because this is containing your root over sign. Denominator is your integer, but numerator is not integer. So as a whole, this is not a rational number. So this is called your irrational numbers. So the definition of irrational numbers you write. The previous class I gave the definitions of integers and rational numbers. So today I am showing them with the help of few examples only, so that you can recall the concept of integers and rational numbers. So based on that concept, now I am giving you the definition of irrational numbers. Right. The numbers which cannot be written in the form of a by b, where a comma b are integers and b is not equal to 0 are known as irrational numbers. For rational numbers a by b, numerator by denominator and both a and b are integers. But here you see, this is also in the form of a by b, but numerator, this is a, is not integer. So this is not rational number. So this is called irrational numbers. For example, you write containing root over sign. for example root 2 by 3, then 5 by root 7. Here is in numerator is integer but denominator is not integer, so this is not a rational number. Then root 2 by root 7. Here numerator denominator both are not integers. Then root 5 also irrational numbers, because root 5 can be written as root 5 by 1, but still numerator is not an integer, so therefore root 5 cannot be taken as integers, etc. So normally the numbers containing root over sign can be taken as irrational numbers. But one important thing is that root 4. Now can you take root over 4 as irrational numbers? Because 4 is also containing the root over sign. So do you think root over 4 is irrational number? The answer is no. Because you can find the perfect square root of this 4. The square root of 4 is 2. So if you can find the perfect square root of any number, then that number containing root over sign, you cannot take it as irrational number. It may contain the root over sign, but still it is your rational number because you can find the perfect square root. But here you see square root of 5. We can't get the perfect square root of 5, so this is irrational. Okay, so those numbers may contain root over sign, but if you can find the perfect square root, that number can be treated as a rational number. Understood? Fine, very good. Next will be, so now rational and irrational numbers understood. Then I will give the definition of real numbers. The real numbers definition, right? The numbers together with rational and irrational numbers are called real numbers. So the real numbers combine all the families of rational and irrational numbers. Then the together of rational and irrational, it is called your real numbers. So rational numbers containing all the natural numbers. Yeah, rational number contain all the real numbers. This rational number contains all the natural numbers, then your integers, then your whole numbers, and irrational numbers already definition given only. So together it is known as real numbers. So in the real number we can have natural numbers. In real numbers we can have whole numbers also. In real numbers we can have integers. In the real numbers you can have rational numbers, and in the real numbers you can have irrational numbers. So with the help of figure I'll explain this. This is your natural numbers. It is inside whole numbers. Whole numbers inside integers, and integers are inside rational numbers. and opposite of rational numbers is called your irrational numbers. And now see these rational and irrational numbers together. Rational and irrational numbers together are known as real numbers. So this figure is very important, and you also make this diagram nicely in your copy. Now one question: do you think all the integers are rational numbers? Yes, all the integers are rational numbers because all the integers are contained in, or all the integers are included in rational numbers. But conversely, do you think all the rational numbers are integers? Answer is no, because you see here 5/7 is a rational number, but this is not an integer. But -5 is an integer. This can be rational numbers. So every integers can be written as irrational. So every integers are rational numbers, but every rational numbers are not integer. For example, 5/7, which is rational, but it is not integer, because in integers we cannot find any fraction. The similar way, you can say that every irrational numbers are real numbers, because all the irrational numbers are contained in real numbers. But the converse is not true. That is, every real number is not an irrational numbers. For example, you see here, take the number 2. This is natural number, this is whole number, this is integer, this is rational also, and this is real number also. Okay, but this 2 is not irrational number, because this 2 is not containing the root over sign. So every real numbers cannot be irrational, but every irrational number can be real number, because all the irrational numbers are contained in real numbers. Okay, fine. Now take some questions from your exercise. Okay, your exercise 1.2, page number 8, textbook. The question number 1 is that in question number 1 you have to verify 3 statements are given. You have to verify whether they are true or false, and you have to justify your answer also. So number 1, it is given that every irrational number is a real number. So your answer is yes, the statement is true. It is true, yes. Because now you have to give your justification, you have to give the reasons in support of your answer. So why every irrational number is a real number? Because every irrational number is a real number because all the irrational numbers are contained in real numbers. So this is the statement number 1. Your second one is that every point on the number line is of the form root over m, where m is any natural number. So statement is given that every point on the number line can be written in the form of root over, and where the root over is containing here m, and where the number under the root should be your natural number. So now is it true or false? So for example, you see here -2, -1, 0, 1, 2, 3. So now this 3 can be written as root over 9, 2 can be written as root over 4, 1 can be written as root over 1, and 0 can be written as root over 0. But you see, in the question it is given that whatever is under the root over sign, here symbol is given m, and that number under the root over sign must be your natural number. But 0 I am writing as root over 0, where the number under the root over sign is not a natural number. So this statement is false, because every number lying on the number line cannot be written in the form of root over sign, where the number under root over should be always natural number. It is not always possible. This is one example. Like this, there are many examples there. So your statement is false. Answer is false, because 0 equal to can be written as root over format as root over 0. So where 0 is not a natural number. The third statement is that every real number is an irrational number. That is totally opposite to the statement given the number 1. So here every real number is an irrational number. Answer is no, because for one example I am giving here in support of the answer. The example is that because 5 is a real number, fine, but it is not an irrational number. So every real number cannot be your irrational numbers. Okay. Now question number 2 is your homework, and question number 3 is that you check your textbook. Question 3 is given that you have to show that how. This question number 2 is homework. Now question number 3, it is given that so how root 5 can be represented on the number line. And this I'll give you one separate video how to represent root over 5 on the number line. So for today this much, and next class we'll discuss about the decimal formats or the decimal expressions of real numbers.